So yeah, I'm finally gonna look at an issue that has been going on and bugging me for weeks now. Some time ago, we discovered, the bug has been known for a long time. There is an issue with Proton and Wine that causes possibly every Unity app, but especially some VTuber apps, to leak memory. And the bug has been known for a very long time. It was a regression introduced in Wine 9 and Proton 9. And I figured out what the bug is, what the root cause is, some time ago, and I filed the bug. The problem is, fixing the bug is quite difficult. And so I filed a draft PR 2 weeks ago with Wine, and it's not exactly perfect. So I want to work on that and see if we can actually make it, something that is mergeable in production. There's some discussion in the bug. That's kind of what I expected, and it's actually a pretty difficult thing to fix. So I'm gonna try to see if I can finally squash this bug once and for all. Who knows? Maybe, possibly today. And yeah, that's that. So let's say hello, another hello, secretive, hello, Arendeke, hello, Ishida, hello, Dragon Knight, hello, Clips, hello, Colors, Runara, hello everyone. Yeah, so that's the plan. It's a bug. It's a really nasty bug. It's a really annoying bug. There's sort of the tension between let's just fix the regression and no, actually the bug is a deeper bug. We need to fix the whole thing. So yeah, it's gonna be an interesting ride. So I think we can just jump right into it. Make sure everything's good here. I think we are. Yep. So this is the PR that I filed, and it's kind of a long story, but basically what happens is, in a real operating system, you have system calls, and when you make a system call, you're jumping into kernel mode, and real operating systems have ways of stopping threads and controlling threads from other threads. In Linux, it's called ptrace, and Windows, it's called getThreadContext and setThreadContext. These functions can only change the context in regular user code, not the kernel code. For obvious reasons, because otherwise you could hack the kernel. The problem is that Wine is a fake kernel, right? Wine is pretending to be a Windows kernel, but it actually runs in user mode on Linux. And so Wine has its own context, its own concept of system calls that are not real system calls. And it has to emulate this whole thing with getThreadContext and setThreadContext in a way that allows, that works the same way as a real OS kernel, but isn't actually one. And that turns out to be really hard. Because it's pretty easy to, say, well, we are currently working on a system call. Deep in a system call, we're just gonna change the context outside the system call. It's pretty easy to say we're not in a system call and nowhere near a system call, and we're just gonna change the context directly. The difficult part is that a system call is not a actual thing in Wine. It's just a function call, and there's a whole bunch of stuff that goes on there. And so the transition between user mode and fake kernel mode is not a single transition like it is in a real OS. It's a whole mess of a function. Turns out when you interrupt a thread in the middle of that function, the context is kind of inconsistent. And that's what causes the memory leak in Unity, because it messes up the garbage collector. So it's a race condition, and the original regression caused the stack pointer to sometimes be completely wrong, as returned by getThreadContext. That's what I tried to fix with this change, and it turns out this change causes a regression, I think, in a test in Wine. And also, there's discussion that, honestly, we should fix this more properly and not just do the sort of regression fix that I was doing. So I actually have, I'm kind of torn between fixing this properly from the beginning or trying to get a patch that is a bit better and doesn't cause regressions first, and then fixing it properly. So I think what I'm going to do is first try to figure out what the regression is and if I can fix it so that at least I can have a patch that people can use while I sort this out. And then try to see if I can fix it properly. Sorry, this is kind of complicated. So first of all, I need to actually run the test suite and the bug that is the issue. I have a wine tree here. There is a whole issue here with the test, and I need to figure out how to run the exact test I'm running. The problem one was NTDLL. There's actually a failed CI here with a test, and it hopefully actually has the issue, because Cyan Nyan wasn't even running the 64-bit tests. For the most part, it only runs the CI in 32-bit mode, which is a bit silly. The code I'm touching only affects 64-bit mode. I don't know if it's broken in 32-bit mode, but I guess nobody really cares, because nobody really uses 32-bit software anymore for important stuff. Certainly not for, like, streaming apps. So the bug here was exception, NTDLL exception. So the first thing I want to see if whether this is actually a regression or whether it's already broken. So I have the patch here. I'm going to just revert it. And just see if the test is even broken at all to begin with, because if it is, I'm, you know... Is this build? Where's my build tree? Here. So let's run that test, just that test, and that's in the wrong place. It's in here. That's a bit slow. I think I want to make it output to standard output if possible. I think there's actually a way of running just the exception test without the wine test story. Yeah, hold on. Let's see if I can just not do that. Yeah, this one. You can do this, I think, and I think that just runs the one test I care about. Okay, so actually, it seems to be very broken. Without the patch? So much for that. Maybe this test was always broken. Huh. Is it just stuck now? Wait, why didn't create process a fail? This does not make any sense. How is it this broken? No. Something's wrong here. This cannot be this broken. Is it because I'm not in the folder? Do I need to be in the folder, or am I need to be in the folder? Hey, there's no way this says it's this broken. What's going on here? RPCS server unavailable. What? No, what's going on here? How can this be? No, there's no way this is this broken. What? Create process A failed? How is that possible? 9 is... Oh, it wants embassy for 30. Oh, because it's trying to run 64. It expects a... it expects a 32-bit? Oh, okay, so that's why. It expects a full wine 32-bit install. Okay, this is annoying. But can I just skip these tests? I don't want to do a whole 32-bit install of wine just for this. Okay, I'm just gonna add a if R return here because at least let's make it not do all this crazy stuff. Okay, so I think we can just do this and ignore those 2 tests. Oh, I didn't want to do wine test. Hold on. Okay, so those 2 tests are just like trying to do... Oh, no. I did not return 102. Did we not build that? Wait, what? I just said if B-rate return. How is it not? Oh, it's a bool return. If... Oh, sorry. If not B-rate. Okay, because this is a bool. Yeah, fine. Fine. I'm dumb. Okay. Okay, that's a little bit better. So that actually just has the 2 failures, which are the ones that we just saw. So that's fine. That's not what I wanted to do. Okay, so now we can revert this. Revert the revert and see if we're breaking something else. Hello.
I'm
okay?
gonna eat Chinese food.
You're gonna eat Chinese food? Okay, see, now this is the actual regression.
Drink water, okay? See you. Bye bye.
Bye bye.
Bye bye.
Bye bye.
Chinese food.
Okay, so I do have a regression. This we need to fix. So the file we are messing with is this one. So let's see if I can fix this regression first, because if I can fix this regression, at least we can present this patch as like a sort of, okay, we are improving the world, even though it's still buggy thing. So Yeah, there's a different approach here, and this is roughly what I want to do. So the first bug I have actually is just this is line 3000. This file is really big. The first bug I have is just that. I don't know if that's the only bug, but we're gonna try it. No, that's still broken. Okay. So let's try doing what this person suggested. Because I think this makes more sense. First, let me rebase and fix this a bit. I'm gonna put the test first, and then the GitLab, and actually put the WoW64 stuff before that. And then as long as I know where this commit is, I can skip it. I'm gonna just leave it there in the history with a revert, actually. So let's see about this change. Switch to user stack, and I just copy this patch. So right before the context integer part, that's right before the end of this function. Right before the red Q here. Here. Should be I red Q. Why did that not apply? Because this is already there? No. Wait, which chunk did failed? Oh, the first one failed. Sorry, 3420. Which is actually the LEAQ up there. Huh?
Type C.
What?
Type C.
Type C what?
Type C to Type C.
Cable? We have plenty of them. There's a bunch in the bedroom. There's...
Help.
What do you mean help? We have tons of Type C cables. What are you talking about?
I can't find.
What do you mean you can't find? There's the ones in the charges in the bedroom. There's there's ones in the living room. That's your keyboard.
Where?
They're probably some in Murasaki in the backpack and the other one. That's
Hi, isn't it?
No, what do you mean nahi? Here's one.
So ugly.
And that has to be a pretty cable too. Okay, let's try this.
Look at the pretty one. So pretty.
Hi.
Bye.
Bye. Okay, that actually works better. I'm gonna just push this for now and then work on the other thing. So, I think I can... Let's reword this. this person have? Yeah, they have. He was co-authored by, okay. Is it suggested by here? They don't use the tag, but I think I can just use that. What just happened here? Okay, so now there's this with the proper fix. Whoa, that's not what I want. Interesting weird thing happened here. Yeah, this is good, okay. So this is the actual fix, as proposed, and that actually works. So I'm gonna just push this, and well, first let me run my test. The one I'm calling is this one. Third CTX. And I think I need a I need a new line in there, possibly. Yeah, they need a new line. Yeah, so that does work. So we're gonna fix that up. I'm just gonna push this because this is an improvement. And we're gonna put this at the top. I'm still not gonna apply this at the top. I'm just gonna say at. Let's do it like that. Let's mark this as not draft anymore. Is it not draft anymore? Did it? Mark is ready. Yes. Now, I know VNyan has their own Maple League fixed fixes. I know that. I gave them that DLL. I patched that DLL for them. I know that. That was me. That's a workaround for this. I patched that DLL so it doesn't trigger the bug anymore. But that's just a hack, though. That's not a real fix. The real fix is this wine thing. So I think I can probably send this PR to Proton. Let's see what the wine people say about it. But even if wine isn't quite happy with it, I think Proton probably would be happy merging this to fix a bunch of Unity stuff. So yeah, let's I'm gonna leave this here. I'll leave this here for now, and let's see if we can actually fix this properly. So I'm gonna get another branch out. And actually, the fixes can stack. Like, there's no reason, you know, to, like, undo the fix we just did. Because it doesn't hurt anything, even if we do a better fix after. So now, the really tricky part is going to be... Yeah, my throat is really bad after speaking way too much yesterday. Split view, vertical... Okay. So, my idea is... Alright, so the problem is this whole function, right? We cannot be returning a context anywhere in this function. Right now, the detection for whether we're in a syscall happens here. Between this line and this line, we are considered to be in a kernel. And the context will be, you know, managed properly. The problem is between the beginning of this function and that line, and between that line and the end of the function. So I think my idea, my theory, my suggestion is between the beginning of the syscall and roughly not just that line, but like where we actually call the syscall, which is like here. Between those 2 points, right before the calling the syscall, actually, I think there should be a test for whether we are about to, or we have a queued stop thread signal. If we have that right before, I mean, you know, before setting up these arguments, whatever it makes sense, before calling the actual syscall, we will, you know, actually process the stop thread. Then, after returning from the syscall, when we are about to restore this user registers and do stuff, there would be another check. Actually, not another check. When after that, what I think makes sense is that if there is a signal right after the system call, the signal handler should actually handle the signal immediately, and then actually restart the return from system call process. So what we actually do is, you know, before this function gets called, we're fine. If we find out we interrupted the thread between the beginning of this function and roughly actually here, this is the kernel stack switch, and then we know that, sorry, we have a consistent, if it's after it's kernel stack switch, we have a consistent context, and we can just handle it immediately. If it's before this point, we have to defer, and then after that, process it. So we need to read through this code and understand where is the best place to handle that, and probably add a flag in the frame that will do that. So if we if we look at the frame here, the frame which is where all the status or all the state for the system is saved. This syscall frame. This is where it is. There's this door on line 2. This sounds like a great place to throw new stuff in. There's restore flags, but I think that's used specifically for important stuff. So I don't know if we want to use that flag structure. Is that used? Is that ever modified to be set? Yeah, there's a context control. This is for handle syscall trap. That might be okay. I don't know what that 40 is. That's a little weird. 66 handle. That's for Apple. I think that's probably okay. Yeah, so I think we can probably use that flag. So there is a incomplete. Yeah, we have extra flags here. I think we can just use that. So we can use this as store flags pending user 1. Let's create a new flag for that. Let's see where we would check that. So all this stuff for the saving is definitely important. For now, the kernel stack, unwind info with the previous terrain. That's for unwinding. I think that is all okay. That is, let's make sure this is actually using. This is DFI stuff. I think that's just our debug. Maybe. Thread data, p thread. Okay, this is doing what? This is messing with FS. And this looks like it's actually pulling out the syscall number and calling it. So, oh, this is the actual syscall. I think we can do. I think we can do the probably do this here. What does the user 1 handler do about FS and GS? That doesn't seem to do anything. I think we can do that here. So let's do it like that. We can move this code if we need to. So, we need to test for the flags. We have the whole flags thing is in here. Is RCX what we think it is? I think it is. probably no. What? Yeah, it is. It's in frame, so we do have that. And we want to test restore flags here, right? Do we have EDX free here? I think we're about to overwrite it, so I think it's safe to just use that. So we need to run a test. If we have a pending user one, then we want to call the user one handler. So we're on the kernel stack. Jump F0 means jump if not that, so 1F. And 1F would be here. And then if we are in this place, we need to call a yeah, like an as a name or something like that. Okay, so we do that. And now to know that it was interrupted before to this point, we need to add a local label here. And there are labels at the end here. Log in, yeah, those things. So we need to add a label like this one. Right here. And this is called the save end. And just need to do it like that. New line and then new line T, yeah. So that's gonna be our marker for before this everything is wrong. And now that's just a safe part. And then we need the opposite thing on restore. So here we call this syscall, and we already have dispatcher return actually. So I think we can just go back to that. Yeah, I think the idea is that we can literally just jump back into the return. The only tricky thing is that this is supposed to be idempotent. Right? We're supposed to be able to interrupt this at any point and go back. And the only thing I'm not sure about is this instrumentation story. I don't really know what that's used for. I don't know if it matters if we call it twice. There's this instrumentation callback, and I'm not sure what this is. Because there's this trace syscall stuff too, and I don't know if, like, is that going to be a problem if we, well, is that going to be a problem if we call it twice? Because how does this context restore even work? Return context integer returns, instrumentation calls the instrumentation callback goes back to integer. Otherwise, this is trace syscall. Oh, that gets called, oh, that's before this is called. Okay, that's fine. But then is that gonna call back? So this gets called before the syscall. And then it's calling what? Is this the actual syscall? Looks like it. So then essentially this trace syscall part, it gets called here. Should be considered part of a stable syscall state. Yeah, so actually, the return part would be from here, from return, to here, to the trace syscall, right? So we need a local label here, which is, I guess it's trace syscall, but I'm gonna add another label here because, return end or something like that. And this is the dangerous part, right? And so... Hello! Welcome to Team Nina. Message retracted? I'm not sure what happened there. So, so then instrumentation is the only one that bothers me. Instrumentation callback gets called like very late, and that's, I'm not sure how important that is. Yeah, so now that instrumentation thing bothers me. I don't know if that's like how common that is. And this is called frame instrumentation callback. Like, what is this used for? What is this used for? Windows, process instrumentation callbacks. So that's basically kind of like ptrace, but local. So it's undocumented for one. And whenever the current prefers to return to user mode, it checks if the instrumentation callback says not null. If it's set, the kernel stops the target user mode RIP with the registered callback address, original function returns to register, and okay, so actually this needs to be, this is essentially considered user mode code, the instrumentation callback, and it's right before return. I think this implementation is just weird then. Because essentially the logical way the instrumentation callback works is that it overwrites the context. Urgent returns into R10 and then RX holds the return value of the system call. So all the other registers are already restored. What this is doing is if it has instrumentation, it goes here. It loads the callback twice, checks. If it's not set, it goes back, which like fine. Otherwise, it sets up the RSP again to the weird return. Checks for context integer. If there's no integer return, it goes back to the regular return. Otherwise, it's swapping it into the return value. And it's returning to it here. REX shows the return value from the system call. Yeah, because it's a return. R10, does it usually get returned? Yeah, it usually gets restored. R10 usually gets restored. Is R10 volatile? Yeah, R10 is volatile. But it does actually get saved and restored. Does it? It doesn't get saved. But if context integer is set, it gets restored. And actually, if context integer is set, it will even ignore the instrumentation flag. So when is context integer set? I guess when you set the full thread context with all the integer registers, which I guess is not done for system calls, because for system calls it just enters here. Restore flags is 0 by default. So normally we don't restore anything. Therefore, this only reapplies when there is no context integer set, and in that case it will pull out and do that instrumentation callback stuff. And that's fine, because it actually is replacing the return value. So, it will actually it's still idempotent. It's not calling the instrumentation call back here. The only problem is this exchange here. That is replacing the return value. So this needs to be idempotentized because it's not right now. That's the only problem then. So how do we fix that? The frame, looking at the frame, we have RIP, and the iRed queue here is gonna pull CS and eFlex, I think. Hello. Yeah, RIP, code segment, and eFlex. So that means we should save the original RIP and then load it somewhere else. Yeah, I think we can just do that. So this is B8. We can't save it here because this is going to be restarted. So what I actually want to do is, instead of exchange queue R10 that, what I want to do is mof queue and the mof queue and this would be B8 to R10. And then I need to actually put that somewhere. So 70 here is the return value. Yeah, this gets saved here, in the pop queue here. Yeah, so okay, do we have the frame anywhere? Frame is RCX here, that's it gets loaded. Okay, so yeah. RCX is the frame. Is it? Where am I? This comes from 98 RBP. RBP is... Actually, RBP here? No, that's not LEA. So RBP is RCX plus 98, and then it gets... Why is that RBP anyway? I guess it can be. And then that gets subtracted and goes back to RCX. I guess that is actually the frame. So we do have RCX here, which makes sense because it's that. So that's RIP. And what register can we use for this? RDX, I guess. Yeah, it should be fine because we're gonna override that here anyway. This is frame RIP. Actually, who sets their store flags instrumentation? Because it needs to be set first. Maybe I can just do it in that call. Handle syscall trap, instrumentation. 6 is handle, instrumentation. Maybe I can just save that elsewhere. Syscall trap. 6 is. Alright, so who sets that? Because when the instrumentation callback is enabled, it's supposed to always do that for every system call. So, how does that work? Instrumentation callback. there's a syscall dispatcher instrumentation. It's replacing those. And syscall dispatcher instrumentation is doing what? Okay, and that is setting the callback. Okay. So in that case, I can just do it here, actually. Only if instrumentation is enabled do we save the RIP twice. And yeah, that's fine then. I think we can just do this. That makes sense. Yeah, we can just do that. It's all safer, so we can just do it here. RCX is syscall frame. And what registers can we... Clobber... Yeah, we can just do that. And then the only issue is that this is considered part of the prologue. So I probably want to put that in front of the function. Oh, it is in front of the function. No, that's Unix call. Gets a little tricky. So this is safe because I probably need to add some comments here. Instrumentation is the only one that needs to move somewhere else. I'm gonna move that in here. So we're gonna do that. And then, and then here, yeah, then here we can do the extra copy. Or even here. So RIP is 70. And where do we want to put that? We can... What register can we clobber? Can we even clobber any registers? I guess I can just use the stack. But actually, R10 is going to be covered if you have instrumentation, so that's fine. R10. Can I even just... I guess I could even, do the callback stuff here, but it doesn't really matter. Yeah. Yeah, that makes sense. Actually, can't I just save it into R10? Because R10 is normally not used. R10 is never saved in this entry point. So I don't even need to use that return thing. I can just grab R10. R10 is never restored in the... Yeah, it's... only restored in context integer, which isn't even used in that case. So, I can just use R10 and I don't even need to do this thing anymore. And so then here, when we do the instrumentation return, this part, we can just take, restore fax instrumentation, this R10, as the callback. It puts that into, the return, and then it moves R10, which is 40, into R10. Yeah, that makes sense. And then we just need to make sure that whenever instrumentation, whenever this flag is set outside of the entry point, we always set RIP to the right thing. Handles is called trap is gonna just override this whole stuff. So yeah, that makes sense. Then we can do this, right? And the same here, right? If instrumentation callback, set that and save rip. Maybe we don't need this one anymore. So I think I can do a commit of just this code. Let me do that. And actually just gonna wanna not do this. Just do this because do not do that. Basically put this in here. You know what, I can just use push Q. It's a little easier. I think that makes sense. Yeah, I think that makes sense. Yeah, we'll go with that. And so, this is on Fedora on Apple Silicon. No, this is on Fedora on regular x86. I'm always impressed by how people do low programming. Thank you so much. So, yeah, I think this is making sense now. And now, if we look at what I actually have, pending user 1, we're just gonna move this to the top. I need to actually fix this so it's actually the same code I just wrote here. So let's put this back. And now we have the building blocks for doing this user one handling properly. So between instrumentation and save end, we set the flag and deal with it that way. And otherwise, if it's after this point, we can just modify the context directly. And then between the return and return end, which is here, we restart the return. And then trace syscall is only called in between those two, so that's fine. That is kernel code. And trace syscall reds is also kernel code. Where is that called? Doesn't one is called dispatcher return. Oh, that's Unix. Okay. Yeah, that's where start thread and stuff like that. That's the global func. It gets... Oh, this loads the stack immediately? Hold on. What is that called? That is... RSP sake frame? I know this called fault. Oh, sorry, that's saving the stack into RCX. Which is the frame, yeah. That's fine. That's considered... No. If the frame... If the RSP is in the frame, that's considered user... Oh, that's not good. Yeah, we don't want to do that. Because then it's actually... We want to keep we want to keep a kernel stack when we call this. Because we're going back to the return. So this should still be kernel code. The only difference is that this is checking syscall trace. And so in that case, this is. Sorry, why is that the only thing that's calling syscall trace? That's only called from here. And that's only called from the fault handler? So we need to make sure that actually the stack here should be the kernel stack. What about bad syscall? What's bad syscall? Yeah, we need to make sure we don't mess with RSP early. So we either treat these as also part of the return, a part of in syscall. Yeah, I don't think that's a good idea. Local label. Wait, why is this putting RSP into RCX as the handler? Yeah. So wait, why is bad syscall using the stack? That doesn't make sense. Why is that grabbing the stack? That's not supposed to be grabbing the stack. Because the stack here is actually RCX. Oh no, is that the frame? It is the frame. Wait, hold on. Kernel stack is the frame? Oh, wait, hold on. Is the frame always at the bottom of the kernel stack, and then greater than frame is when you add that? Ah, okay. So then the frame is fine. It's just under that is not fine. Okay, so in syscall, get signal stack, a signal stack size. Where is that initialized? Okay, yeah, it is the kernel stack minus frame size. Init process, yeah. Kernel stack. Starts at the end of that, and then the syscall frame is like aligned under the kernel stack. So who allocates the kernel stack? The allocation stack. Oh wait, no, this is the end of the kernel stack. Okay, so the kernel stack starts at the end of, and then the syscall frame is allocated right in. I always get confused because stacks go backwards. Kernel stack is this kernel stack is the base of the kernel stack. This is the top of the kernel stack. So the kernel stack ends right before the syscall frame. And then, so then what? So then that Unix private is inside signal stack. Kernel stack is thread data. So this is actually the kernel stack, and then okay, yeah, just gets syscall frame. Yeah, okay. So between the kernel stack and less than or equal to the syscall frame is in a syscall. If it's inside that, then it's when it considers it to be out of syscall. So that's fine then. And in that case, this is all good. In that case, these are okay because these are using the stack inside the in kernel mode. The only problem is if it gets interrupted literally at this instruction, I guess. No, it doesn't, because RSP is where it's set. It's fine. So this one's fine. Bad syscall is also fine. Although I don't know why it's taking RSP from that. Is RSP actually set to the right thing here? It does. It is set to the right thing. Yes. So it's fine. Okay. Okay, it's fine. So these are all good. Once it switches to the kernel stack, that's fine. So this is all good. Anything that's not within these bounds that is on the kernel stack is considered to be inside syscall and safe to modify the context. And then here, between return and return end is when we check that. So we need these labels, global pointers for these. And then the instrumentation callback is the beginning, and the save end is what we need to save. Save end pointer, save end. And so between instrumentation callback and that is when we do those things. Okay. That makes sense. And so finally, in the user1 handler, we need to check all that. So we have this PTR stuff here that is used before. Yeah, this kind of stuff. If RIP-sig on uContext is greater than or equal, and we need the syscall instrumentation one, which is this one. IP-sig is that should be 64-bit, so and RP-sig is less than save end pointer. Then we want to do this thing with the frame, right? So we get syscall frame. Actually no, because in this case, syscall frame is going to be overwritten by the entry point. So the restore flex is going to be set here, actually. So that's a little bit tricky. So we can't use that, actually. We should use a different flag somewhere. So probably shouldn't use that then. What we could do is just kind of now processing this code manually is a little painful. Because they're all no. Let's use a different flag. It's got extra flags. So you load extra flags and tester 1. And that should clear that. Um, so if it's between return pointer and return end pointer, and I'm just gonna move this entire code into a function. I'll give it a U context in here. And I probably want to put a trace in here somewhere. And now I need the deferred syscall 1 thing here, which is how do you want to call that? So there's a user 1 inside syscall, and also first of all in thread there's a where the frame is initialized. I want to make sure this is something interesting. Where's that? Not fault. Where's the thread in itself? I need to make sure that field is initialized to 0, because otherwise it's going to be very confused. I don't know if that is actually cleared anywhere, so context. Signal init process. I think that's this one here. And there's that whole previous frame thing here. I need to see how to do that. I guess when we chain them... oh, this is a little problematic, because if we have a pending sync user 1, I really want that pending sync user 1 to be a global, so maybe it should be in the TB instead of in the frame, because it's not really a frame at that point. Because this is nesting thing, right? Thread data syscall frame. Yeah, I think we need a thread data. Yeah, it should be in here actually. Yeah, it should be in thread data, I think. So we probably just want to put it here. What's NTDL thread data? It should be in the local one then. Should probably be here then. Oh, and this is actually a different thing, yeah. So, let's jump off. I think you can add another. Oh, this is called trace flag. Can we reduce that? This is a flag. Trace on syscall. What's that? Oh, it's actually a flag for like. Okay, interesting. Start thread. Sure. We can just reuse that actually. Yeah, we can reuse this. It's called trace flag. Because it's just a single flag there. So... yeah, we can do that. Actually, that's a lot easier. And then I need to grab the frame. How do we get that? Just entity get 3 there, okay. Yeah, and then I finally need to the defer code. So for defer, so we're on the right stack at this point. We can just call things, I think. And then I don't know what to do with this uContext. It's checking... I need to get, like... this is... Xcontext is looking inside the stack. What do I do with that? I don't know what to do about uContext here. Looks like we have the frame. What this is doing is... it clears the X state. Something compaction enabled. Oh, FPU sig is whether there is a FPU signal. I guess I can just use get context. Is that used anywhere here? Not exactly, but so this is actually doing it. It's using the uContext. Takes a stack, subtracts 128, red zone, and then so it makes some space in the kernel stack. It sets the then it does a get thread context, okay. But what uContext? uContext, yeah, okay. So that's just this is making space in the stack, in the kernel stack. So then, because we're not on a signal stack in this point, how does that even? I forgot. I forgot how signal stacks work. Yeah. Cyan Nyan. Hello. Hi. So hold on. This is well, we're in a. Isn't the signal supposed to already be jumping in the context? So why is this? No, because the signal happens. The signal happens. Yeah, how does signal handling work? Does this just syscalls stack? It does do a syscalls stack, okay. Yeah, okay, there's a signal stack. But we're not in a signal anymore when we defer. So what is this? Is putting up some space in the kernel stack. And then it gets the context. Does stuff. It doesn't wait to spend on context C, but shouldn't this be getting the frame? It should be using the frame. Because we're inside a syscall. And I guess that's what get to the context is gonna do. Yeah, so it pulls the context into the... Okay, yeah, so it's just a buffer at this point. Yeah, it's just a buffer. So it's just grabbing a buffer so it's not inside the syscall. Yeah, okay. So what we actually need here is literally just buffer, and then what's this fix up frame FPU state? I guess we need to call that too. Oh, because that's in Unix called dispatcher, okay. So fix a frame of view state is called only in the Unix call case. Restore facts in complete frame context is called only from Unix call, so it should not ever be deferred. So that should never happen in deferred mode. So in deferred mode, we just want to do that. Yeah, so it's basically this context frame here, right? So I think we can just move this earlier and have this separate. In this case, it's not U context. It's literally just the X context that we actually want to pass here. Take that out. We do need to get the frame, and safe compaction is that. Yeah, so move this back. And then that's only called from here. So what we can do is move this in here. And then this would just be grammar context like that. So this is not U context, this is context. Take that back. And then I think I missed something with the context C in here. This. Okay. Let me do a good diff. Let's see if this makes sense. So we have, we don't need the third local flex anymore. Third local flex, that goes away. Okay. So reuse a bit for that. Okay, cool. Shared code to handle syscalls without even a syscall. Oh, I didn't need a return. This is the return here. Well, let's see if this works. Probably not gonna compile that easy. But there's Yep, definitely not. Not that bad. Yeah, so it used to be called the uint pointer, whatever that was. U-long pointer. Invalid use of void expression. Wait, hold on. PTR, how are these called? Oh, okay, they are, yeah, their values. So the actual value is the pointer. You don't need to dereference it. And then, wait, so is there an X context here that is outside of syscall, it just goes in the signal stack? That's a little strange. The original code has... Yeah, there's a context. It uses a... So, if it's inside syscall, it grabs the context from the kernel stack. Otherwise, it uses the signal stack. That's a little bit strange. I'm not really sure why it's doing that then. I mean, we can still do that, but oh, I did a format at some point. Oh no. Oh no, I did a format in here at some point. There, don't do that. This is not kind of formatted. I'm too used to using a formatter. Actually, you can just use that even because it's just gonna override it. And then we just need frame. Deferred sick user one defined but not used. Okay, so what is this called? Advanced syscall. I guess it's asm local label? No. Probably need to be global for that to work. Okay. Tests. That looks like we broke stuff. Definitely broke stuff. But it started running at least, so it didn't completely break everything, but something is wrong. What's the default debug channel for this thing? Unwind and SEH. Yeah, there's a loop here. What's going on? Access violation. Great. Yeah, so it's crashing inside a syscall, it looks like. But where? The address is some random low address. Or if I just disable the segv handler and just let it crash. Okay, that is very broken. Huh. Okay. Where is this code? 72568. No, FEC002. That's like nothing. That's like, huh? Some kind of, thunk or something? Okay, well, clearly I broke something really bad. Add global function table. What does that even do? It just adds it adds a function, and then somehow it's segfaulting inside that function? How does it segfault in the pop, though? Oh, because it's RAX is... Okay, yeah, because it's, This is a crash? Oh, it might be doing this on purpose, then. This is probably a... this is a segfault test. Okay, so that's not it. This is a test that's explicitly causing a segfault. But that does not help us. I probably should just run it under GDB without the... with that, and just let it continue. Yeah, so that one is a test. And then what is it doing? It's unhappy. Ah, why? It's like it's infinite looping? But then it's actually dying, like, really badly. Okay, maybe GDB breaks it. Okay, I'll be right back. I'm gonna take a very quick break. I'm back. Okay, let's see if we can make sense of where this crash is happening. So that's a lot of loops. But I did catch it. So this is red loops. Breakpoint, some other stuff, whatever. This is the loop. Not brave instruction, those are fine. Access violation, okay. No, this is still fine. This one, this is the loop. No, this is the test. Hold on. This is the actual loop. Okay, so what happened here? There's a single step, a breakpoint, then an access violation, and then we loop. So is the issue returning from a breakpoint? Ignoring harder breakpoint in syscall. That could be interesting. The test, okay, so there's some breakpoint stuff here. Collided exception handler. There's an instrumentation callback handler thing too. That could be the problem. That doesn't quite look like a correct RIP. That looks really random. How do I run the tests? Can I do like verbose? So like a wine test trace or something? Wine test debug, how do I check that? Okay, it needs to be wine test debug. By default's the 1 though. Actually, let me just run my test first because let's see if this actually fixes the problem. It doesn't. Interesting. Okay. So it does do the deferred user one. Deferred user one during syscall entry. Handling deferred user one. And then there's a fault. A really random address. Okay, so we are broken. Fixing this is probably easier than whatever was happening before. What is that IP? That cannot be right. Okay, so user one's fine, but the problem is it's okay. I need to like continue user one. How does that work? No stop. Like that. Okay, run. Okay, so we are crashing inside the signal, inside the handler probably. So we are crashing there, and I'm off from EAX. Oh, I know. Okay, yeah, I know what happened because we're calling the deferred handler, and that's clobbering registers here. How does that work? R13 is non-volatile. Okay, this is failing in RCX. Because we need to reload that. Yeah, that's why. Okay, well, yeah, obviously. Okay, that makes sense. RCX is literally just a stack at this point. So if we're not pushing anything, we can just grab that again. This LEA is fine, actually. It comes from RBP, which is... yeah, that. So we can just do that again, actually. Hey, that actually is working now. Okay, it did crash. The rewind worked once and did not work the second time. Nested exception signal stack address. Okay. Let's try GDB again. So this time we crashed in another mob from REX, which is a totally broken pointer. Okay, interesting. Where's that code? I don't know what this code is. This didn't add RSI, REX, and REX is really big, and that's coming from RSI. I don't know what this code is. Doesn't look like the safe handler. So this is in 72 1F9. 72. 72 is NTDLL, unsurprisingly. Why do we have symbols? Can we get symbols in here? That'd be nice. It says not stripped. It does have symbols, so why is it not showing them? Is it the architecture mess? Now what happened? Kinda looks like we are doing something that we're not supposed to be doing. Where is the backtrace? The backtrace here is... Still no idea what this code is. E167 BC. That's another call. What is this function? So why are there no symbols? Can I build this with symbols? Yes, enable Win64. Are you gonna recompile the whole thing now? That was not that useful. Is it just because it didn't... Did it actually compile with G? It did. Okay, let's try that again. Okay, now I did something, but did not. It does have functions. I got a 72.3 EFF. D2. Yes, NTDL starts at this. Five, 6 EFF, okay. Context to server. Okay, that makes sense. And it's probably then, did it die in a defer, or what happened here? It died in a rewind. Or possibly a rewind. Maybe my the exit here is not idempotent. That would be an easy explanation. Oh, wait, this is pulling from RCX. We need to have the frame in RCX. Which does get overridden. Yeah, okay. Yeah, okay, that's probably the problem. Let's try without GB now. That's looking better. That's looking a lot better. And while I'm here, I can make this possibly also fail if we get a value that is not in user space. I'm not sure how to test for that though. Hey, it does work. Is that used anywhere? The is it any kind of like is kernel address or something like that? Like, how do I check if it's in a P or in Unix? There's probably some way I can do this. Like, reliably. There's a loader. That's the preloader, though, I think. I don't think this is that. No. How does load library work? Kernel 32. Sounds like it would be there. Or not? So I think in Winbase, but where is it actually declared? Kernel-based loader. Okay, that makes sense. Loader load DLL. Where is that? Uh-huh. That is an entity loader. That makes sense. Arbitrary user pointer sounds related. Yellow base, where does that come from? Might be this map view of section thing that actually does the... It probably actually pulls in the... client pointer, address pointer. There's probably this limit high thing, right? Highest starting address. Where does that come from? Okay, it isn't here. There's a highest user address, and that is that's all 64. That's not. Oh, there's only 164. It's only 164. User space limit. But that's not right. Because there's something that is lowering that. Okay, this address is here at the top. Yeah, it doesn't come from that. Server mapping. Okay. Okay, yeah, it uses those. I think we can just check like that. We can go say is I think that works for the test. Okay, it does fail. It did catch an RIP that is lower because it's actually the test. Yeah, because image space is that. I think you can just use the default. Can I like grab a define Windows define 64-bit? There's gotta be someone to define that I can use for that. IOP32 and stuff like that, right? Yeah. Or maybe not. No, that's for Linux. Oh, Win64? Ah, yeah, that's what it is. I think you can just do it like this. Address is less than this match. Actually, no, it's this. Like, do it properly. It failed with... Wait, 1401? It does. It is pretty high. Okay, whatever. Let's do it like that. I think it works. it looks like it works. I might be able to do one more check. Is there any register I can use to kind of like use as a sentinel and see if it ever gets overwritten? I'm not sure if it's gonna be very useful, but it might. Maybe some kind of floating point thing. No, but the kernel wouldn't really override those. Let's see what it does. Let's see what is overwritten here that we can do as a test. Not really. RBX, RBP, RDI, RSI, 12, 13, 14, 15. Yeah, those are all the... Also the code segment and the stack segment. So those all need to be preserved, and the other should not matter for the GC roots, so that should be fine. And the next time 6 through 15 are non-volatile. But they could be used by any Windows call, so that's not that useful. Are there any registers I can just steal as a test? Probably not. Nah, I don't think there's anything easy we can do. Oh, we'll keep that for now. Okay, so now does it run the other tests? Exception. That doesn't look right. I think we still have a problem. So at least we are passing my tests. Which is very good. But we still have some problem. Oh, what are those errors? This exception on single stack. Oh, that doesn't sound right. That doesn't quite sound right. That's actually on a board, so clearly something is wrong here. Yeah, that's wrong. Which means the test should actually do something else at the end. It should do, that'll probably catch that. Oh, even worse. Okay, so what's going on here? Exception frame not in stack limits. I guess I can just GDB and look for a sec fault. There we go, there's still a sec fault here, okay. 947. Still on rewind. Still on rewind. Uh-huh. Possibly still missing some kind of idempotency issue. Shouldn't be instrumentation, so what is causing this then? Okay, let's see where it stopped, because that might be useful. B972. Okay. So that one got called exactly, wait, there? No. No, it has to be there. I think. No? What? B972. Three E972. It is there. Okay, yeah. Exactly here. So exactly at dispatcher return. Does that make sense? Did I overwrite it? Am I just being silly? Yes, because I'm already overwriting it. Okay, now it's at BA5C. And that's a push RCX. Oh, right, the stack. Wait, no, the stack should be fine because we are. Wait, should it be fine? Oh, wait, hold on. No, we just set RCX, which is the return pointer. So the stack should be fine. This is actually crashing right before return. So it got caught. It got caught exactly. Here, right? Yeah. So I think something is not idempotent here. Oh, the stack. Wait, no, we got the return. We switch to the user stack immediately, so it should be fine. As long as RCX is what we think it is. So the actual crash here happened in D21987. I think it's all on the same address. CCD. 54987. to server. Okay, REX is crazy. And REX here is... how's it? Keep forgetting how to dump memory. And DB this X. Yeah, something's wrong here. This is an address, and then we have a... Okay, what is that state to server thing? Okay, so this X state is invalid. It's pulling an offset. That is crazy. Context to server, and we do call these from here, so... Yeah, wait suspend calls, context to server. I think I'm doing something wrong here. Oh, hold on. No, context. State to server. Context and exit. This is the problem. Ah, wait, hold on. Context and say context. I can't. Oh, hold on. Oh, this has something to do with it. Because this is assuming, normally this would be using a context that is in the syscalls stack. with the frame. Oh, that's why it's using that. That's why it allocates it there. So am I in the wrong stack somehow? Yeah, I must be on the wrong stack. That did not work. Yeah, okay, that's the problem. This gets called with a context that is in the kernel stack. And then it breaks. User 1 inside syscall. Okay, so it's always after a rewind. Why is it always after a rewind? Oh, because this is taking the stack from... Ah, the stack is probably already restored to the user one. So we need to go back to the RSP sig. Okay, so just double checking this here. The return happens here, and the first thing it does is move the first thing is to switch to the user stack. And at this point, though, RCX, the kernel stack we're supposed to be using, is supposed to actually be RCX. So yes. Okay, I think we're getting somewhere. That's looking good. Almost. Alright, another bug. What happened now? So those were fine, but then this is crazy. Whatever happened there. That is a crazy address. So at this point, the syscall frame is crazy. And actually right before that, we got this, which also doesn't look right. These look right. That does not look right. So we didn't get deferred syscall. We just ended up here. So it wasn't deferred. Okay, let's add more traces. User one inside syscall does the X state, gets the context. Wait, user one inside. Oh, because it's multiple threads. Yeah, okay. The one that crashed is F1, F4, which is somehow calling this twice. Okay, that's not right. What's going on? It did a rewind. And then it did the init X state. And then somehow we're doing that again in that thread. So save context does do that. So it does a rewind. And then it ends up calling save context. But it didn't go through the outside syscall path. So what happened here? Rewinding syscall. And that one was fine. Now before. And then it just does save context. It's like we're looping some weird stuff here. I guess print the print the segv handler. It might just be the segv handler being very confused. Okay, yeah, there's a seg fault going on. And then after that it gets confused, I guess. Okay, so GDB again. So the rewind is causing a seg fault. Okay, back to GDB. Am I using multiple monitors? No, just one. Alright, so now we have a stack. 3EBA9. Okay, we're back at the syscall dispatcher. Oh, this is interesting. Okay. R13. Did we break R13? We might have. Huh. R13 is thread data. But this is the safe part of the code. Wait, is R13 not saved? No, 13 is saved, so it should not be. That should not be the problem. I guess R13 is null there. That's not good. Oh, yeah, this is the return, and the return okay, yeah. Right. Of course. This needs an R13. Yeah, it needs it. It needs the current TEP, that's why. We just need to set that up. What about RBP? Probably also needs RBP. RBP is also supposed to be the... It's supposed to be 98, frame 98. We can just jump here. That'll be right. And then the syscall trace is going to trace. Yeah, that's just trace is called ret. I guess we can just manually set that up. Huh? Oh, that was weird. Slight glitch for the music. Sanity check. No, we're good. Okay. Yeah. Okay. Let me see. Makes sense. So I need an RDP. Let's also set RSP. Because why not? I mean, I guess we don't really need to set RSP because we're restarting it there, but yeah, we can just do that then and skip that. We're getting close to making this work. Nice. What about the exception tests? Ah, we still have this loop, so this is a different problem then. What is that? Okay. Let me undo these debug deletes. Oh, whoops. Where's the access violation now? There. Okay, so there's an issue with single stepping. The X-State calls look okay. You got me a giant pink plushie, thank you! Okay, there's a sec fault there, and I don't know where it is because this is just jumping. So I guess, the interesting thing is that this is not really hitting any of the corner cases I'm doing. So that means I regressed something with my changes outside of the special cases I'm trying to deal with. Which means git diff, and let's see if I can audit what's going on here. So we have user one inside syscall, which is the same as this code here. And that uses the RSP sig. Yeah, it's just copy and paste. So what this code is doing is pulling just a bunch of pointers. So it's not even hitting user 1, which means the problem has to be in something I changed in these. Should not be in the instrumentation stuff. So what's going on here? This test R13. I'm testing the same thing, so it can't possibly be breaking there. It's not actually calling that. Oh, do I have a 1F or something I'm breaking at some point? No. Okay, so it's not that. Huh, but I didn't really change anything. How is it possible that if it's not the user 1 handler... Because the only thing I did was... So is this testing instrumentation by any chance? The problem is that I can't really run GDB on that test because it's failing everywhere. Let me try that again. Oh, is it this context in exact state with nil? Oh, that. No, it does check that. But it sounds really sus. There's a setup basic section. Okay. Here's the breakpoint stuff. Where's that seg fault? Guess I'm printing the RIP on here. I should dispatch the test that only runs this one test. Okay, so here's the access violation. Yes, it is .RIP. And that's R10. Oh, wait, R10? Is this the... Ah, is this the handler thing? Oh, we're jumping into the same thing as R10. Oh yeah, something. This has to do with the instrumentation then. Ah, okay. Huh. Yeah, because that's not an image base, so that's some random address that's not supposed to be there. Yeah. So something is restoring R10 into... There's a breakpoint at some random address. And then we are somehow returning into the instrumentation callback without restoring R10. Okay, what happened here? Yeah, okay, it's the instrumentation callback. Uh-huh, okay. It sets the instrumentation callback, then it ends up setting a, and someone gets a breakpoint. What's the test doing there? Test instrumentation callback. Instrumentation callback handler. Breakpoint. Okay, this is the breakpoint story. Hey, Mary! Nice to see you here. We're so close. We're so close. How about I just also print the syscalls? Very unhappy. No. Okay, let's try, maybe I can make this abort. Yeah, okay, so I can at least make it abort instead of loop. Now that I know that the problem has to do with those two tests. There we go. Here's a breakpoint, and then it dies. The breakpoint has R10 set to that. It's possible there's like an uninitialized flag somewhere. What does anti-continue do? Signal set full context. This is not even changing the syscall frame. Yeah, I think this is a bug that was already there. Possibly. Because it sets the full context and that overwrites R10. Okay, so maybe I just can't use that slot for that. No, but that only overwrites R10 if you have context integer. And if we have context integer, the instrumentation stuff does not run. Is it really just uninitialized at this point? It might be a bug, a different bug. Because we have breakpoint exceptions. Yeah, so there's a trap handler that calls setup raise exception. And then NT continue is calling signal set full context. Which sets the frame context. So this is like setting the instrumentation thing again. Yeah, that's a bug. So why are we going back through the syscall return path? NT raise exception. Handle interrupt. Call user exception dispatcher. Is that what's going on? It says ignoring hardware breakpoint in syscall. And that's a crazy address. That might be right if it's... Might I? I'm not sure. Is this used for exceptions or just for system calls? It's executed on kernel user mode returns. Okay, so all of them. Okay, so who calls this? Who specifies this return thing? Here's one. Returning to user mode rip. Ah, okay, here's one. It's probably one case here. No, wait, so what about this R10 thing? Hold on. Are we losing R10 in that case? This is confusing because if the instrumentation callback uses R10, then where does the original value of R10 get stored? And otherwise you can't have this in exceptions. I guess it does happen when you call the exception handler, but not on return back from an exception. That would kind of make sense. So, so the problem is not the yeah, the problem is this is called dispatcher return. This here handles is called fault. This is a return to user mode. This cannot be doing the instrumentation stuff. So who calls handles is called fault. Okay, that's a SegVi handler. Did this happen twice? There's a SegVi handler, and then that happens normally. Yeah, okay. So I think returning to handler would be fine. That is that should be configuring the R10 stuff. No, that's just a long jump. It just returns to the handler, okay. Otherwise, if it returns to user mode... Yeah, we need to set the restore flags properly. Those need to be cleared. So if we are inside of syscall and we get a fault, what it's doing is it's jumping out back into user mode. And in this case, we need to is it possible the instrumentation callback was set at this point? No. No, that's not it. That returns true, ignoring how we bring for in syscall rape. Okay. So the trap handler gets called, ignores that in the syscall. Let me add some traces here. I suspect some stuff in here. Did you find and fix several bugs in several projects? I mean, this is all wine, but I think I'm finding more than one bug in wine. Okay. So we are actually getting a set fault in that, so something is returning. Anti-race exception. Call user accepting dispatcher sounds like what we're looking for. Yeah, that makes sense. So restore flex context control. I think this is the problem. But why? How is this returning? Is the question. This is returning from what? It's returning from Oh, this is a system call. Okay, anti-race exception is a system call. And then on return, it breaks. So anti-continue is fine. Okay, that makes sense. So anti-race exception is replacing the sys return with a user exception dispatcher. That's why. And then the reason is that this needs to check for the instrumentation callback here. Okay. The problem is that a system call can return to a different place. That's why we have a problem. Anywhere that says sets a frame RIP needs to check for this. And it's actually doing this anyway, like this dance here too, so. Does instrumentation work with frame control? And we have restore flex instrumentation. Goes here. It checks for integer and then returns. Okay. So you only do the instrumentation if integer is not saved. Because otherwise we cannot do the instrumentation. So, Just to be safe on this one. My throat is so weird. Okay, so this is the missing one here. And now, hopefully this actually works. I don't know if it did. Still got a sec fault. And right a wrong place. Okay. So it's still not working. There's a user one thing there. Actually, no, is it fine? I don't see it. Wait, no, maybe it's just the tests that are known to be failing. Hold on. It's not with the support because it might actually be normal. No, it's not. Okay. Okay, so what's after breaking point? Can I catch it? Okay, so breakpoint, NT continue, NT raise exception, returns, and then crashes Y. It's called user exception handler. Oh, I forgot this one. Hold on. Because it's not APC, it's the other one. Sorry, I need to do this too. Wrong one. It's this one. Nope. Oh wow, there's a weird exception now. Now this is different. What is this? Okay, this is raising a custom exception. This is a different thing now. There's a custom exception. This it's getting this far. And then it does anti-separate context. And that happens during the syscall, yeah, so... but probably because, I bet this is also set. RTL capture context. I bet it's because we're not restoring integer registers. Right, what I actually need to do is check for frame, restore flags, and integer. Because we don't force restore the integer registers unless they were already getting restored. That looks better. That looks way better! Hold on. Let's try without the syscall debug. "14 failures." Okay, but at least it's not dying really badly. But we expected 2 failures due to the WoW 64 stuff. Okay, so which failures are failing? Okay, it's just these, I think. 11426. Some context did not get restored. Or something. What is going on in this test? This test is testing. Extended context. Oh, is it just that do I just need to clear like a context and I'm not clearing it? No, it's missing data. Okay, now it seems we are not setting some... RTL capture context. Was this passing before? Okay, let me just fix some of this stuff. This has to go into... There's a fix-up for this one. And then we do the user one pending stuff. No. Let's add the fixes for this stuff. So let's get stash. And try without all those changes. Okay, we saw 14 failures. If I go before that change. Oh, we saw 14 failures. Okay, no, that was still broken. Apparently we still have some failures here. If I literally go for Git master, oh, that's gonna complain about the I need this one. No, we still have 14 failures. Never mind. Is it because I'm setting wind test debug 1? No, I don't know. Okay, I don't know what's going on with that. So then did this... What did the pipeline say here? It did pass on 64, okay. Interesting, so then why are those failing? Is it because I'm combining with debug mode? Because that wasn't happening before. Oh, I just didn't. Oh, wow. So apparently combining in debug mode breaks some of the tests. Okay, well, that's not my problem. Let's go back to where we were. And what just happened here? Oh no, wrong. I'm looking for this one. Hello, hello. There we go, 2 failures. Okay, cool. And if I run my thread CDX, awesome! It works! Alright, let's remove some debug from here that we probably don't need. Deferred is fine. We want to do those because those are the special cases. And otherwise we can just do this. Okay, that makes sense. And finally, we can actually just revert the previous commit because we don't need that. So let's rebase. And we're gonna reword that one a bit, and we can drop that commit. That's not necessary. And we can move all this around. So first fix it, then add the test, then the abort fix, and then run the entity tests. There we go. And then run the test again. Looks like it works. Exception. Just the two failures we expect. And what about if we just run everything? Well, a lot of them are not going to pass. I'm just going to push this to get that then. I'm going to change this comment a little bit. And I don't think this even needs sign-offs, actually. Yeah, people don't sign things off here, so... I can just drop that sign-off from that one. And I think there was another bug mentioned that I probably should also check. 54807. That doesn't look right. That's kind of a different issue, though. Okay, I'm just gonna send this and see how it looks. All right. Just open the MR. What just happened here? Huh? I think it's like... Okay. So what's going on there? So this rich text editor. That's why this is so confused. Okay. Turn this off. Should have used plain text. Okay, let's see if the pipeline is happy about this one. It's gonna take a while to run, and there we go. Ah, finally. This actually, I'm kind of happy with how that worked. The instrumentation callback stuff is a little dodgy. I suspect they might tell me to just just put the right callback in the put the right value in R10 and put the callback in the return and simplify that, which is fine. Yeah, I think we're pretty good. You're doing pretty good. Do you want to do other stuff today, or do you want to just call it a day? How long has it been? 5 hours, not bad. What other things do I need to do? There's some pipe wire bug fixing I want to do, but maybe now's not the time for that. What other stuff? I thought of something at the beginning of the stream and I completely forgot. I didn't say it. Oh, I was gonna do some packaging stuff for Spout to PW, but I don't really feel like starting all that right now either. I need to like install Fedora on a laptop and look at a different bug, but that's kind of like not very nice to stream because, you know, different machine and HDMI and things. I think I might just call it a day and have a short work stream today. Maybe I can even stream with Cyan in the evening, we'll see. Alright, I think I'm gonna call it a day. Please remember you can support me and please subscribe and join the team if you can, or support me on GitHub sponsors. The links are on the top right there. And yeah, if you like what I do, please do please do support me because I can only work on so much stuff. You know, I don't even make money by doing this, so yeah. What else? Let me think about something. I wonder if I want to send something to Proton, but I think we want to wait until this. Oh, let's see if at least if the pipeline runs before I actually end the stream. I would like to at least see if the tests are gonna pass. So we're gonna wait a little bit for that before actually saying bye. It might be a good idea. Actually, you know what? At least I'm going to see if I can rebase this on top of Proton. Because... interesting. Wow, this Git modules use like relative paths? Oh wow, I did not know that that was a thing that could happen. That's very interesting. I had no idea that was the thing that would work. Let's see if I can rebase this on top of the Proton wine. I'm gonna grab that silver wine, fetch Proton. And I guess that means I need to fork this on GitHub also. And so this is from 2 months ago. Looks like the commit they have. What version of Proton is this? Is Proton 10.0? Probably want experimental 10.0 or something like that, because bleeding edge is probably Proton 11. No, actually it's 10. So it's 15 hours ago. Yeah, sounds about right. 729F00. Let's see if I can grab this particular commit. This is very recent. Sounds right. And take two. I think I can just cherry pick. And of course, we are going to have conflicts. Oh, I do not. What do we have? We did not get anything. I want me git config. I do the three-way merge thing. I would like to do that. I like the conflict. Yeah, this one, div 3. That's what I want. Okay, it is there, sorry. Parent. Yes, it's just adding that. That's fine. This part did work. Then we have and just that. Okay. User one handler is inside syscall takes an RSP. So that all changed. Use private. That takes it to context, okay. Yeah, that's fine. This one we can keep. But then this is all weird. Definitely gonna have to do this. And that starts at context flags, which is the same. Make sure this is all actually the same. It did change. Just the compaction stuff. And then, hopefully this is the same. Yeah. And this part should be the same until there. Yeah, it's just the context flags. That did not change. Okay, good. And then everything else is the same. Okay, that's fine. And then the assembly, okay. This is a lot of stuff. Parent. Say an argument. Oh, 0, 0. It can be 0. I guess the frame is different. There's a syscall flags. Either way, this is obviously what's going on here, so keep that. And syscall trace, we need to double check that. Is that even there? If we don't have that, that's going to be quite annoying. It is not there. Oh no. I guess I need to add a flag here. Painful. Thread data. Does any thread data happen here? MXCSR. That's the CPU data. And 330 is syscall table, which also is in AMD 64. I guess I can just do it on this one then. F0 to 350 is 60, which is 12. We still have space. Okay. $350. What is this called, Fax? That's in frame. But I don't want the frame. I want thread data. syscall it here. $350. And that is at 350. Within that, and that's using GS, so I guess we can just use that. Does this work with Testo? I'm not sure actually. Should try and see if it files. Hmm. What changed? I'm not even sure what changed here. How about that is in the other way around, but I don't know if that might actually just be a mistake I made, actually. Okay. And then this is just like, okay, this is open coded. Let's see if that compiles. I'm not sure about that test, if I can do a GS override test like that, but let's see. There's no configure. Oh, Altigen. One CI fail. No, I do expect the CI to fail because there's random stuff that fails that I have no idea what's going on. But which one failed is the question. Oh, wait, the build failed? Interesting. Huh? Okay, I can fix that. I can fix that. Yeah, that's the only thing. Okay, I can fix that. And yeah, we have stuff here that needs to be changed. There's no get syscall frame. 6 sys handler. Wait, what? Oh, sorry, different one. Apparently there's random files that modify when you compile. That's weird, but okay. I need that. And the same issue here. It's funny, that one didn't happen locally, but happened in the CI. It's inside syscall. It's just ucontext, I think, on this one. Yeah. Huh. That's not. Pass storage class for function. What? That's interesting. Huh? Is this just a broken test that doesn't even compile? It's not this, right? No. I have no idea why all these things are changing. Like, are these auto-generated files? Oh wow, there's a to-do line here that is like just completely wrong. That is just a very broken patch. Yeah, while that compiles, I'm gonna take a quick break. I'm back. What now? Another broken test? I guess they just don't test compiling the test. What? I do want to build the test, you know? What now? Trunk F? Another broken test? Come on, I understand not having the test pass, but not having the test even compile isn't that a little bit too yabai? Does it need like a libm? Yeah, I have no idea. Oh, another one. Def prop type. How's the CI going? Okay, now it failed on Linux 64. That's interesting. Empty map view section returned. Huh. So virtual failed. That might already be broken. No, but it passed on the other one, so maybe it did break something. Need to investigate that. Oh, the others are good though, including exception, so that's good. Okay, back to this one for a second. See if I figure out this build. Okay, let's try the virtual test. That did not break when I run it, so what gives? Maybe it's just random. Maybe it's one of those like flaky ones. What is this error code? Status process is terminating. That sounds uninteresting. Is that just a timeout? That kind of sounds like a timeout. But not really? That sounds like a fluke. In the tests. Am I the right? Yes. Tests. $15.48. Now that sounds like a timeout for like the overall thing. How many minutes would it pass? No, not that many. Oh no, it's probably because thread TTX is too long. And yeah, okay, it's a timeout because thread TTX is taking too much time, and then the overall thing has a timeout of some number of seconds. Okay, yeah, that makes sense. Because it's 100. Yeah, so it was. Yeah, okay. Let's make this 80 sec. 90-second max runtime. It's just a little bit too tight with my test timing. That should fix that. Why did the Win 10 test fail? New story. Oh wow. My tests fail in Windows 10. Oh, because Windows 10 doesn't have the. Yeah, okay. I need to mark that particular test as wine only because otherwise, these are gonna be different. Yeah, I need to make that. That doesn't make any sense on Windows. And also this needs a new line, apparently. Yeah, on Windows it uses higher addresses. How do I check for that? I used to have this documentation open somewhere. Writing of conformance tests. try that. And back to this mess on... Oh gosh. The baby codec. Can I just like not do this? Is it just struct? Probably just struct. But I bet this is not. That cannot possibly compile. I have no idea how this is so broken. Yeah, this is not gonna work. There's some internal thing here that is not like it's accessing. Why is it doing that? From FFmpeg. Why? Can I just turn it off? I don't need this. Disable FFmpeg or something like that. Yeah, please. I never imagined the Proton build would be so broken. Okay, looks like we're getting somewhere. Oh no, OpenCL? Can I without OpenCL? What about Proton G? I wonder if they'd be okay with like a merge there. What wine are they using? Okay, this is Valve software. And that is just 10, so. Do you have any patches? Wine hotfixes, some of that might make sense. Okay, now it builds. That did not... Wait, VTS does not exist? Did I not? Oh, I didn't even... Okay. I didn't even cherry pick everything yet. No, I did. I just did not, I need to do that. And then this one, okay, fine. That doesn't actually matter. There's no thread stack limits. Okay. There is. Missing an include? No. Huh. Oh, it needs like a P. Okay. Is that like a Windows thing? So we have Windows 8 and later. How does that work? Oh, okay, it works like it funks like that. Sure. Looks like it's not crashing. That's a good thing. Yeah, that worked. And the exception tests. Whoa, stuck overflow. That's not good. Let's just do all this stuff. That's a fix up for this one. And then this is a fix up for those. Let's just do a checkout of this and see if it still breaks. Okay, no, it does pass the tests. More at least. Except I probably need to fix the WoW 64 one. Yeah. Okay, so I'm getting 4 failures as a baseline. Exception.c failed to load library, whatever. Commands. Yeah, that I think it's just the wine 64 stuff. So going back to my branch. That is certainly unhappy. Stack Overflow could just be because I'm actually using Stack. Or it could be actually because it's looping. It does kind of look like it's looping. It does look like it's looping. Does it? Yeah, access violation on... on instrumentation plus 9. Yeah, that sounds like my problem. Oh, I bet I messed something up here. Ah, I did mess this up. How did I mess that up? there we go. 4 failures. Yeah, that's what I messed up. Okay. I had a weird thing with the merge there where I was really confused. Alright, so this is a Proton rebase that seems to actually work. Uh-huh. Cool. Yeah, I have no idea what these changes are. If I just stash this. Interesting. Looks like it's some kind of patches that happen or configure, or I don't know. I think there's a patch file, like some kind of patch file gets applied. It's automatically generated, that's why. Okay, yeah. I think these are probably all just automatically generated things. Alright. I think that works. Is memory leaks the thing that makes the app consume all RAM sometimes? Yes, that problem, yes. Alright. So I know there's people who are doing this without AI and know what they're doing. Maybe I don't think AI knows how to do this. You know, people did stuff before AI, right? Syscall. What do I call this? And we don't really need the other test. So, yeah, I think I can just push this. And I need to add my GitHub remote. How are we doing with the CI? Still running? Hey, it passes! It passes all the tests on 64. Hopefully 32 is not gonna break. Oh, some of those actually were failing before, but have nothing to do with me, so... Good. So now, just go in here and get me a branch here. And this is not the right branch to be comparing against because this is experiment bleeding edge is what it is. Yeah, there you go. So I think I can just send this to some people and I don't know if it's rebasable into Proton 10 because it says bleeding edge. Let's try 10.0. So basically just delete 40. It does rebase, so I think we can just I think they will just apply on Proton 10.0. Just push it on GitHub anyway, but yeah, I think that one file built, so it's probably fine. Or not? 1911? It does build though, yeah. Oh no, but it's a Unix one though. Does it build? It does build. Yeah, it should work. Okay, good. Check. I think I'm gonna call it a day. We have it's been almost 7 hours now, and it looks like this pipeline is working. The 32-bit tests take a while, but I mean, actually, nothing that changes 32-bit, so there's no reason for these tests to fail. So anything that fails here is not my problem. My changes are only on 64-bit, so yeah. Alright, I think I'm gonna call it a day. Good thing I got a Proton rebase done, because people kind of need that. And hopefully, this will solve a bunch of problems with Proton. Once this is, wait a few days to see what the wine people say, or send it to Proton or to Proton GE. Does Proton take PRs? How does it work even? Is there's a VAFSO for wine? There's pull requests. I guess they do manual merges. Yeah, they go into Bleeding Edge or Proton 10. Can you stream a bit longer to do some random work? Why? What? What are you doing? Patches like to get backported to Proton once more upstream. Yes, but this patch, as you just saw, I had to do a bunch of work to backport it. So I think I'm in a better position to backport it since I just wrote it. So they do accept patches like this before, so apparently they send them upstream first. I guess they wanted merged upstream first and then backported into Proton. I'm gonna sneak into the house before you kick me off what I bought. Sorry, I think I'm gonna be done. I might open a PR. This is, yeah, it's on the bleeding edge. Syscall raise. Let's just go and open this. Jesus, I'm still in the sinful place. I think I'm done. Sorry. I think I'm gonna call it a day. And I have a few people to ping about this. Hopefully this will help some people. So yeah. Good thing this fix is now looking pretty good. It's looking pretty legit. I don't know what upstream will say exactly about this, but yeah. Alright, everyone, thank you for watching. As I said before, please do support me if you can, because it's really difficult to spend a lot of time working on this kind of stuff unpaid. So every little bit counts. Links up there in the top right corner. Alright, thank you for coming. I'll see y'all next time. Bye bye, bye bye.